So the first build is always, you know, the occasion to look at the final design flows that we have. As you can see here, I just kind of vacuum formed the canopy just in order to see what's happening and these kind of things. But in any case, so one of the first problem that I've seen is that it's the back strengthener, okay, that was a little bit flush. That explains why this is a little bit wide here. So that's one problem. The second problem is that the holes here for the landing gears were not deep enough. So that means that I had some hard time in order to make sure that I was in the correct position. Um, then what? Then the support of this air intake here, whatever, was really too thin. So that means that it was really prone to break. So of course that was not really good. Then after that, in the cockpit itself, I've seen that the little crank that there is in order to modify the forward ailerons and whatever, I mean that was really too small. So everybody will lose it and whatever. So I will integrate that directly, I would say. Then after that, if you look well, you can see that the second line here has not been carved out, as well as the Karman of the back wing has not been carved out. So that means that the cut was not successful. Then after that, normally in the top view, you can see that there is strict lines here and here, and so of course that is still missing here. Um, the junction of the rudder is really too thin, so it breaks. So I have to strengthen that a little bit more. Um, the alignment of the engine cooling here is also a little bit difficult. So especially because, as you can see here, normally there is a gap, but I didn't manage to do it at the first sight. Um, then what there is it's not it's a little bit more difficult to see here, but there is a little deformation here on the wing. So I don't know if you will manage to see it, but there is a little deformation. So that means that I need to make sure that here I could eventually, I would say, correct it only with filing and grinding, but I think it's good that I had an internal strengthener in the wing in a way. And also the last point is a little bit more on the aesthetic part, but as you can see or don't see it because it's too close. But there is a big hole here, and normally you should see the first cylinder of the Renier engine, so I will certainly add that. So as you can see, that's something like I don't know, like 11 design flows that I've somehow detected, and so I will correct all those 11 things before providing the final version on my different accounts.
So I told you that there is a little problem with the back strengthener here. As you can see, it's completely flush here with respect to the half of or the middle of the fuselage, where in fact in the design there is a little gap of 50 microns here, as you can see. And the idea was to make sure that I can put those things together, even if that's inflated and whatever. But in fact, in the back, where that's exactly the same profile, it turns out that the junction here is done in such a way that he didn't manage to really do a proper job in terms of, let's say, intersection. And well, at the end of the day, that means that this thing here is flush And I tried all the possible tricks that I knew in order to get back these 50 microns, but I couldn't manage to do it. So that means that the only solution is, unfortunately, to grind it after printing in order to make sure that in fact those things here are kind of connecting, because I do not have any other solutions. When I'm trying to cope with that problem, either the chain of command is not working anymore, because that's a pretty long chain, as you can see, with a slice and everything like that, together with the fuselage interior that you can see here. Okay, so the fuselage interior should be cut with that thing, and when you look it, you see here that there is in fact this kind of 50 microns here, but unfortunately when you cut it into the fuselage, then these 50 microns has disappeared. And as I said, I tried a lot of things, and none of it was working. A lot of things were kind of crashing the model itself and everything. So as I said, okay, we will have to deal that in the physical way and not in the design way. Another thing that I said that I need to improve is the holes that are used for the landing gear. This one is not deep enough, so it's not really helping in terms of I would say putting the things together. In fact, what I've done is that I've added some sections here in order to have the cut at the level of the holes for the landing gear. So that shows me that in fact here it's not shallow enough in a way, or it's too shallow, whatever. So that means that I need to work on that. So in order to improve that, I first need to explain to you how I've done the landing gear. So to do the landing gear, what I've done is that I've defined those section here which are just sketches in order to have I would say the proper in a way the proper plane or datum from the front. So what I've done is that with those things here, I've created those datums, okay, which are roughly at the position, I would say, of the sections that are of interest to me. As you can see here, there is those two datums here, and there is this datum here that correspond to that. Now, I've used those datums in a way in order to create those profiles, and I will show you the profiles. So every time, those profiles, they are pretty simple. I didn't want to, make things too complex. So at the end of the day, it's just an arc and then two straight lines, and that finished with something which is the minimum thickness that I'm using. Okay, and I've done that for both. I would say the section that you see on the top, and then the mid section. So these two profiles are exactly the profiles that are matching, I would say, the right view, okay, the view from, I would say, or the left, okay, I always have problem with that, and also this view here. So that means that with those two profiles, I'm able to do this kind of thing here. And then a little bit the same thing, I mean, from this profile that you see here, what I've done is that I've created something which goes a little bit below in a way, which is this one, by just adding a kind of an attachment offset of minus 17 millimeters, which is this distance from here to here. Okay, and of course I've designed, I would say, the profile in such a way that it matches the view here, and in a certain way the width here. and that allows me to create, I would say, this landing gear bottom grounded here. So now I have those two things. In order to remove that, I cut that with a piece here. I think that, so again, that's very easy. You draw this kind of shape and then you do an extrude. Because of the fact that this was going really close to here, I think that I had to add a tolerance of 50 microns, and that gave me, I would say, this landing gear bottom here. So you begin to see how I've created that. So now for the and then of course for the ground axis, it's not really very difficult. It's just something that a sketch that I used as a revolve, and that gives me this basic shape here, which is the basic shape of the landing gear. So all that is nice, but what's really interesting is, I would say, the top part of it. And the top part of it is simply you start from this profile, of course, and then I've used a sweep. And in fact, I've swept, I would say, the profile under that sweep here. And this is where things get interesting, because if I'm looking at that sweep now only, in a way, together with my cut, um, I should have a way in order to basically direct the. So if I do, I should have a way to direct. That's a little bit strange. So why I don't see all the rest? I will come back to you. I will manage to do that. Yeah, so it's normal not to see anything, because the sections that I'm using, are using, I would say, the holes in a way, and so that means that this thing depends on this arc, so you cannot see the things that are down the chain when you are editing these things. So this is why it's completely normal. So if I wanted to see a little bit better where we are, that means that I should do a section with the things that are before, okay? So that means without the holes, which is a little bit the thing that I will do, and again, I will come back to you. So I went down, I would say, the tree in order to find one of the, I would say, deepest primitives in which my hole will be, or my junction with landing gear will be, and this is what I found here. So in fact, if I'm saying that I want this to be visible, and then I'm editing this sketch here, I'm getting something like that. Okay, and you can see here that it's really close to the border here. So how will I do that? Well, in fact, I will use one of the new features, which is the intersection here, and I will say that I would like to have that. Will that work? No, I will have to say I want to see a line view to sketch. Yeah, and I want that. Yes, so it worked. Hey, look at that. That's pretty good. Okay, so that means that I have this section here, which is the one, the intersection that I'm interested in. So what I will do is that I will not keep that, because that's a little bit too complex in a way. But what I will do is that I will do a kind of segment here. On that segment, I will block it. Okay. And now this spline, I will remove it one way or another. Okay, shoot. This spline, I will remove it. Super. And now I can make that, I would say, construction geometry. And what I will do is that somehow I will make sure that this point, is orthogonal to this. That's the first thing, and that it's a little bit, I would say, deeper in the thing. So what will I do is that I will say that I do not want that anymore. Okay, so that's my first point here. Okay, and it seems that I have an angle here of 5 degrees. I will say I do not want that anymore, neither. Okay, and what I will say is that I will say that this to this will be like a distance dimension of something like global sheet resin thickness divided by 2. Okay. Okay, so as you can see, that's a little bit better. And this, I do not want that anymore, neither. And now I should be able to somehow control that. So I would say that this and this should be orthogonal. Okay, and now I just have to control that a little bit according to the view which is underneath. So now I have only 1 degree of freedom, which is the height of this final point. So in fact, I will just say that the height of this final point will be 425. And all of a sudden, I've done something which allows me, in a way, to control much more where I am. From there, once you have this sweep here, it's pretty easy. You can define the thing that will be the hole around it. So in fact, this is why you have something which is a little bit like that will define the hole. In fact, I could even go a little bit deeper in the resin width, but I was a little bit afraid about the fact that I would eat into the resin width. So this is why I have added in my fusion. I have added somehow. Where is it now? It's somewhere in there. I have added a strengthener in order to make sure that I would not have, I would say, something too thin in terms of resin. And this is why I've done something like the top matter here, which is here I have the tolerance as an offset, and here I have the resin width as an offset, which basically gave me some matter that I can add into the fuselage in order to make sure that I will not eat the thing. And at the end of the day, that gives me this common here, which is I would say the one that I'm using, and that will allow to position correctly. I would say the thing. I'm a little bit surprised that with my tuning and everything, it's not really orthogonal to this layer here, but that's okay. That's okay. My guess is that yeah. Well, again, that moves a lot, so it's for example, for the end, it's a little bit better. So okay, so that's it, and of course, I can do the same thing for the two bottom struts here, but I give you here the idea, and I've done that. For the struts, it's roughly the same thing. So that means that you start from from sorry, from this profile here, then you add, whoops, another profile. Okay, sorry, it's computing again. Then you add another profile here, and that allows you to build this thing here. And then you start from, I would say, that profile here, and you control it through an extrude. So that means that where is it? So that's an extrude, which is this one. Yeah, I have the rear here. Sorry, this is why I was a little bit confused. And in fact, this extrude, you just, I would say, controlling it through the direction of the extrude. And this is how I went from here to the rest of the fuselage by tuning, I would say, the dimension of this. So that's roughly the same idea. And then at the end of the day, you have the full landing gear, which is something like that. And the same techniques in order to get the inside of the fuselage. So that's it. This is the complete explanation about how I've built my landing gear, and I've been carving in, I would say, some holes into the fuselage in order to be able to glue it and to correct it. So the next correction is about the air scoop, okay, which is this little thing here, as you can see it, okay, which is basically the air scoop itself on the support, okay, which is in that case revolve. So that's a little bit too bad, because I will not be able to use a revolve, because I need to have something a little bit more wide. So instead of having a round section that I got through the revolve, what I will do is that I will do a kind of section that will be wider. So in order to reuse what I've done for the support, I will start from this sketch here. But in fact, I will select this, and I will create a sketch normal to this edge, okay? And since I have that, I have now, for example, I can integrate through the projection, integrate this here. And what I will do is that I will do something that will be a little bit like that. Okay, so that means that this and this will be aligned, and this and this associated to that will be symmetric in a way. And now the only thing that I have to tune, well, I'm not sure about this symmetry, to tell you the truth, so I will stop that symmetry here. What I will do simply is I will have from this to this like 0.5, and from here to here something like 0.8. Okay, and normally that should fully constrain here. What's the degree of freedom that I have here? No, this and this should be horizontal. Okay, close. And I think normally that should be, so like if I do, did I made a mistake? That's the question. I don't think so. Okay, where is it? It's here. Okay, so that means that now if I do an extrude of this, of I don't know, 1 millimeter, and 1.5. So in fact, in order to look at this sketch here, the scoops, I see that constraints, I have 1.5 millimeter. So that means that here in this extrude, I should have a 1.5 millimeter, 1.5 millimeter. And now now, for me, it's just enough to look at the air scoop itself to see if I'm good in terms of, let's say, positioning. So in fact, I think I made a mistake. So that means that, for example, in this sketch, without editing it, okay, I can see that this 0.8 here is more like 0.5, and that this 0.5 is more like 1.2 or something like that, in order to have something which is a little bit better, or even 1.5. And that means that my air scoop here ready, instead of having this fusion here, it's simply the fusion between the air scoop on my new air scope support here, which is okay. Recompute. Yes. And all of a sudden, I should have my air scoop that should be a little bit better attached to the fuselage. So this is another correction. Concerning the structure lines, perhaps you've seen it, or I will show it to you anyway, is that the back Karman were not really carved out or carved in into the fuselage. So in fact, you have to understand that this is a kind of a tricky situation, because of course you are at the junction of the two shapes, which is the Karman on the fuselage and everything, and so every kind of very small variation is susceptible to provoke a break. So that's why sometimes you have to play with in the orders of the cuts that you are doing, in order to make sure that at the end you are okay. And in fact, the front Karman is doing well, okay, because basically, I mean, as you can see here, I would say the fuselage is kind of not very complex shape and whatever, but we know that at the end here, especially in this area here, the fuselage shapes are pretty complex, and that's where things are broken in a way. And so usually when you do the cuts, either the cut is coming back saying it's an error, or the cut is going back okay, returning okay, but in fact it's not completely effective, and that's what happened here in a way. So this is why I had to redo completely, I would say, the sequence of cuts. And of course, the problem is that, so here, for example, you can see that I had to do the cuts of the fuel cap, okay, before doing the cuts of the back Karman, because if not, that was not working. And after the cuts of the back Karman, I would say the solid itself is not very well defined, and this is why you cannot do any more any fusion. So you have to do a compound, for example, in order to add the air scoop. So sometimes you have to do those kind of things in order to make sure that you can go up to the end. And for example, here I see that I have a little problem here, so I will have also to I would say correct that again. So okay, that's the correction of my. Yeah, okay, this is not a problem. This is the air scoop and whatever. Okay, so that's the kind of things that you have to do if you want to go further. Another problem that I've seen is that there is I've lost already 3 times the little lever here that is associated with the dashboard. So my guess is that it would be better to integrate that lever into the dashboard, because if not, everybody will lose that part. And furthermore, there is no way that this will hold in a 72 scale. So I will integrate that. So the way of doing it, it's So for this, the only thing that I have to do is to remove the hole that there is here. So it's pretty easy. You go there, you edit that thing, and you say that this thing here should be there, and then you close it. Which means that the cockpit is now something like that, and in fact you can add that lever here. So that means that this fusion now it should be added with that lever. So yeah, okay, I compute, and now I have that lever integrated. So that's pretty easy. So another problem was a slight deformation near the hole here, especially about the big wing. So in fact, that was pretty easy to understand because again the hole inside, sorry, the hole inside the plane is kind of big in a way. So what I've done is that I've taken that mid profile here that you can see here, okay, and associated to that mid profile, I've created a back wing strengthener here that I've extruded, and I have integrated that into again the tool of the tool in a way, in order to remove things from this back wing interior adjusted. And at the end of the day, that gives me something that is like that, that allows me in a way to keep the kind of rib inside, I would say, the fuselage. So at the end of the day, that gives me something which is exactly what I wanted in a way, which is this strengthener here. So which is exactly at the middle of the hole that is into this wing. Of course, we can see it. Sorry, we can see it here. So that's not really okay. But the resin can flow freely outside, and on the other hand, because of this junction here, it should hold the wing in place. Now, perhaps the deformation is a little bit closer to that, so I will have to see if that's the case, and if that's the case, I will have to find another way of doing it. So that's another problem solved. Another problem is the fact that this extra piece that I have added in order to represent, I would say, the kind of sheet, metal sheet that you can see close to the rudder. The problem is that at the end of the day, this is too thin. If you look, in fact, that's 0.1 millimeter in one direction and 0.1 millimeter in the other direction. That's way too thin, and so that means that I think that the minimum that I can accept in that scale is around 0.3 millimeter or 0.4 millimeter. Now the problem is that I would like that to be the same independent of the scale. I would like it to be always 0.1 millimeter or 0.3 millimeter. So the outside is a little bit depending on the scale. So this 0.1 millimeter here, which is the outside, I will let it the same way, in a way, associated to that metal sheet. But the inside should be linked to the resin width in a way. So that means that, for example, if the direction is X, then I would say that this would be global sheet resin thickness divided by 3. Okay, so that's going to be a little bit more, so I will let it go here. Yes, of course, I made a mistake. That was not this one, that was the other one that I wanted to change. When done on the proper direction, that gives that, of course. And then I will take that label here, okay? Because when I doing the rudder, of course, here in the direction here, that is on the -2 this time, what I will do is that I will take this here, length rev, plus the global sheet, whoops, global sheet tolerance. So if I want to change that again, then of course I will be okay. And in my direction, I don't need a -2, I need a -1, so I don't know why I had 2 here, but that's okay. And so this means that normally we compute, this should be okay after that. So that means that here I have a good thing here. And so if I'm looking also at that, which is cut after that, normally my last part should be all good at the end of the day. So if I take my compound here, you can see that here it's good, and that should be a little bit easier in order not to have everything falling apart. Another stroke line that I had forgotten in the first iteration was those 2 stroke lines here that are in the wings inside, in fact. So, I mean, from the top view, it can be seen that there is those stroke lines here. So I had to do something about it. Fortunately, there is not that much to be done, because at the end of the day, remember I had those this cut here, which is the thing that I have used in order to tune up my Karman. Sorry, that was this one here. Okay, and in fact for me it was enough to cut it. Okay, in order to get this thing here as a surface, and then to offset it. And basically that was allowing me to offset it externally and internally in order to make sure that I could cut that through the wing in a way, because remember, here we are very close to the Karman, and also here it's a little bit tricky. I mean, of course, you don't see it too much here on the front wing, but on the back wing, you can see here that because of the angle, it's a little bit tricky. Luckily, I was able just to use that directly, and to include that into all the things that I was carving into the middle fuselage in order to get to that without any issue. So that was kind of easy in a way. And yes, I think that I have forgot some back wing offset cut. Yes, okay. In any case, so that was going very well, and this is how I've extracted um, these stroke lines from both wings, the front wing and the back wing. Seems that I have modified something in my display in order to have those points here. I don't know where they're coming from. I will have to check that in a way. Anyway, so that was the thing. That was another thing that I had to do before going to the final version. So the last addition that I've done to this model on the correction is the little pins here in order to be able to better align the front fuselage when I will glue it, you know. And well, this is kind of easy to do in a way. So I will show you. Easy to do, but nevertheless. So it all starts with a kind of what I'm calling the pin stop, and I think I have the base here, which is this thing here. Sorry. Okay, so you have both this, which is gonna be the basis, and this is gonna be the pin, just 1 millimeter extra outside of the parts in a way. So how do I do that? So I will take, for example, for the profile, not the base, but the top. So you do an extrude, then you do the cut with, I would say, the skin. So you obtain this thing. You cannot do both the top and the bottom at the same time because offset does not allow to offset kind of non-adjacent surfaces. So in fact, once you have that, you are doing what I'm calling the deep, which is twice 2.5 the resin thickness. But I'm doing the same offset in a way, which is this time the resin thickness minus the tolerance in a way. So that will give me, when I will cut those two things together, this thing. And then I'm adding with the same kind of technique the base, okay? And this allows me to do I would say the trick in a way. And so that gives me this top pin here, which is the one that I'm showing here. I have the same thing for the bottom pin here, and at the end of the day, I'm doing all that with a big fusion that I'm doing at that level. And as you can see, this will give me the first cut that you can see here with those two pins completely integrated. So that's fairly easy in a way. And then I'm removing the front Karman stroke lines. As from there, I think that the system is still good. So that means that, for example, when I'm doing, yeah, I think that I have a compound here. No, I have a common here, which is this middle first. So here, when I'm looking at this common here, this common is good. So that means that here, except that you can see here that the stroke line for the wings, I've added that also, are good, except for the bottom part here, which is not very good. Okay, so that means that the bottom part of the Karman here is not very good. That's somehow I don't understand exactly why, but nevertheless, it's working in terms of when I'm looking at at the model itself, it's working well. So I have my stroke lines that are here. So in fact, I will stay hit. So normally, this is the last correction that I wanted to add, which means that now I will be able to export that and to replace, to upgrade those parts in Lychee Slicer and to do the final print. The last correction that I've done is a little bit more an aesthetic one. As you can see here, from the front side, I mean, okay, not on this view, but on the front view of the FANA, you can see that you can see here one of the cylinders of the Régnier engine. And so I've done something very simple. I've copied the little I would say, the little shape of that cylinder that I have, done a revolution, a revolve around that, and I have added that to the spinner junction just in order to have a little bit of, let's say, dress up of the front engine, because if not, it's just full of holes and everything. So I think that normally here there should be a grid also, but that's okay. I mean, that was enough for me in order to finish up that model. I'm not looking for a very perfect model. Again, that model is really a demonstration about how to build I would say, a pretty accurate model from A to Z.